Hi everyone, welcome to our another session on System Architecture Foundation. Today we are going to talk about building blocks of our architecture, but quick recap on what we've studied or we went through. So we talked about what is the purpose of this series, and as you are aware, we understood that now with the things evolving, with AI coming into picture, it's very important that we keep ourselves technically aware. We are technically fluent and we understand the language of engineering, right? Because we are no longer responsible just for ensuring there is a stakeholder engagement. You are acting as a facilitator, or you are the one who is driving the communication, but you are also acting as a strategic enabler. And for that, it's very important for us to understand some of the technical jargons and what is the purpose of those technical jargons. That would help you understand more about your stakeholders, that would help you understand more about risk and dependencies which you can foresee beforehand, rather somebody coming to you and telling you about those risk and dependencies. We talked about what drives system architecture. So we understood it's all the requirement. Your requirement act as a source of truth, and the requirements drive your system architecture. We uh, saw an example wherein, for example, if there is certain governance or compliance required for the system which you're building, then your approach would be totally different as compared to if there's no compliance or governance. Also, you have to take care of things like GDPR, which is your data privacy. And if we talk about AI, it's about the ethic, governance. So a lot of things, right? So based on your requirement, your system architectures are defined. Then we also understood about the attributes, quality attribute of your system architecture. They won't be written specifically or categorically in the requirement, but you will understand, okay, what is the purpose of this system? Is it high availability or scalability? Are we okay with single point of failure? Are we okay with having some latency in the system, etc.? So based on your system requirement, you'll understand about the quality attribute of your system. And what a good quality attribute? We high scalability, availability, your system are performant. And we also talked about why proactive monitoring, etc., also helps us to ensure that the availability, scalability, performance, etc., are not hampered, right? You're able to reduce the blast radius of an issue. Okay. So today we are going to talk about some of the building blocks of these system architecture, and the next session would be all about your backend services. So five key building blocks will study, which is like your load balancer, DNS, message broker, API gateway, CDN, etc. Now, what are your load balancers? You can consider them as your traffic hop, which helps you distribute the traffic, right? So we know we want to ensure that our systems are highly available and they scale based on demand, right? But we still need some software or some devices which helps us in equal distribution of these traffic. So there comes your load balancer. There are various kind. You can have your hardware load balancer, software, or virtual type. And how are your load distributed? Again, there are various algorithm, round robin, circular, but everything would depend upon your health of the server, right? So health, why it is important to ensure that your servers are healthy before we route the traffic, because if your servers are not healthy and you end up diverting your traffic to those faulty servers, you'll see impact on your quality attribute of availability, right? Yeah. So how do we ensure we are meeting our quality attribute? So yes, you are directing your traffic to healthy servers. You are scaling based on demand. You're ensuring that your traffic is not routed to a single server. Rather, it's equally distributed. Hence, we'll be able to serve the client request more effectively. And how we are ensuring fault tolerance? Same way, ensuring that based on health, based on CPU utilization, memory, etc., all these parameters, we are distributing our traffic. So there could be some open source load balancers which you've heard about, example Nginx, right? Or there's a cloud equivalent of those load balancers as well, right? So you know, like in AWS you have application load balancer, network load balancer, etc. And how our traffic diverted, it is based on the algorithm, based on what is it that you are setting at a load balancer. Next important building block is your message broker. But before we go to message broker, it's very important to understand what exactly we mean by synchronous communication and asynchronous communication. That will help you appreciate the working of messaging broker better, right? So in case of synchronous communication, we consider system as, okay, you have got a client, would send the request, it would go to the server would respond to your request, and until you get the response, your client would be waiting, right? You see those processing or loading bar, etc. So we see this doesn't gives a good experience to the user, right? Also, if there would be a failure in one of the fulfillment service, it would impact other requests as well, and then you have to do the retry. All the retry, etc., is again adding to your response time, right? So if you see simple example, for example, we went to a front end system, say payment, right? So you've got a checkout page wherein you just entered your details, you picked type of payment you want to do, whether it is going to be through your net banking or through UPI, etc. So that request would go to your backend services. Now your backend services or fulfillment services would further be talking to banking, notification services, OTP services, card processing, and anything which fails at this layer would lead to retry, right? And there would be a cascading failure. Yeah. So this synchronous communication is good when your system is very simple, but we are talking about distributed system, large scale systems, right? So where we can't wait for response to be back from the server. Take a simple example, like you go to restaurant, right? You place an order, and the moment you place an order, you get the receipt that, okay, your order has been placed. You are not waiting at the counter, you go, you sit, right? And then there are chefs who are working on your order. Yeah. But if it would have been synchronous, like, okay, you place the order, it would go to chef, and then the order would be placed to you. So the process would become so slow for people who are lying in the queue, right? Who are standing in the queue. But what we see happens in restaurant, you just place your order, you get a confirmation that your order has been placed, you take seat, you're talking, discussing, and then when your order is ready, you are call your order number, etc., is called, and you go and get the order, right? Okay. So synchronous, we understood, it's like simple. You send a request through a client, you wait for response from the servers, and whole process is little slow. But in messaging broker, what we are doing is we are using a asynchronous architecture, wherein, okay, you place a request, okay, and these message broker, they use concept of queue, right? So your request, it is stored in your messaging queue, same as, okay, you've placed the order, you get the receipt, you're happy, you are sitting at the table, once your order is processed, your number would be called out, right? So similarly, you're here, the moment you're placing an order, you're doing any transaction, you'll get a confirmation that, yes, okay, your order has been placed. But the processing happens in the back end, which happens asynchronously. Okay? And there are a lot of ways queues are implemented. They also do your validations, they help you route the messages to the right servers, etc., right? And you would have heard about event driven architecture or a publisher and subscriber pattern, right? So we'll cover about these in detail, but for now, just understand that between your front end and your fulfillment servers, there is a component which we call it as a message broker which queues your message, right? So this way you're providing high availability, right? You queue up all the requests, you follow that FIFO logic, first in first out, you're parallelly processing so many requests, so and client doesn't have to wait, right? Client would get the confirmation, okay, my order has been processed, and then you get your order once it is fulfilled, right? Okay, so we've covered two building blocks till now. Your load balancer, which are acting as your traffic cop, right? So these things, they are very easy to understand if you map it to the real world, right? For example, okay, we said load balancer is acting like a traffic cop. Now go and observe how whenever you come across lot of traffic, right? So lot of traffic is lot of requests. See how your traffic cop is managing, right? How the traffic cop is routing the request. Similarly, for message broker, simple. When you're processing an order, sorry, when you are placing an order, see what all is happening, either online or offline. So it would be very easy for you to relate to these concepts. Now, third very important concept is API gateway, right? So here again, for you to understand the working of API gateway, some things to understand is monolithic versus microservice architecture or API composition, right? So earlier, if we talk about say YouTube, for example, imagine you've got a single service or a single code which does all of these, like upload, helps you upload, manage comments, profile, subscription, etc. Till the time the application is small, deployment development is easy. But moment we want to add some other features, managing this single monolithic application would become very difficult, right? So with this as a problem statement, what came into picture is for every feature you go ahead and create a independent service, right? So you'll have a front end, so your YouTube, yeah, front end. And then okay, for video, uploading video or watching video, there would be a different service. For notification, there would be different service, a service to manage component, sorry, comment, etc. Then your user profile, which would have the subscription details. So all this single monolithic architecture we've divided into simple services, right? Micro services. So what do we mean by service? It's like it's serving certain purpose. So you've divided into simple services. But with that, what would happen? So with API gateway, if you have got, you've there are multiple servers, okay, and now if we don't have anything in between, right? So you've got your client, you've got your API gateway. Again, the API gateway can sit behind load balancer, right? So if we don't have API gateway or intermediately level for any services we want to interact with, any services, whether it is a front end, video service, notification service, etc., we every time from front end, when request goes to video service, there would be authentication, there would be authorization, right? So you're adding to overhead, the processing time would increase. So hence came into picture your API gateway. So they are between your client and your servers, right? They act as a layer. So all the things which these independent services are supposed to do, like authentication, authorization, ensuring security, would all be taken care by your API gateway. Okay. And now your these services, the independent service, video services, etc., they don't have to do all of these things, right? If there is like a DDoS attack, you're getting a lot of requests from one system, API gateway would have something called as a rate limit, like how many requests it would allow, right? So now that is being taken care by API gateway. All those requests is not going to your servers directly. All the authentication, authorization, everything is being taken care by API gateway itself. But one thing which is very important for us to understand is uh, without like avoid putting your business logic at a API gateway layer. Your independent services, like these services, should have the business logic. But what is the role of API gateway? To do all these common things like authentication, authorization, rate limiting, also caching the frequently used resources, right? So anything which is being requested time and again, you cache it at your at API gateway layer. So what you're doing, you're avoiding the network hop, right, from your client then to your load balancer to then your API gateway and then to your server. Now here we know, okay, there are certain requests which is being accessed again and again. So what we'll do, we'll take those take those response or take those resources and we'll cache it at the API gateway layer itself. Okay. Uh, Again, it helps in seamless refactoring or modification, right? So if you want to change anything at this layer, video service notification, user won't get to know, right? Or your front end system, for front end system, how it would interact with these backend services, it is interacting through API gateway. So anything which changes at this layer, API gateway would manage, right? These services don't have to manage those changes, right? So refactoring and internal modification becomes easier. Adding a new services also becomes very, very easy. Yeah. Again, monitoring and alerting, as I said, you don't have to if you are monitoring your API gateway layer, you're able to prevent all those fault, all those spikes, etc., way ahead before the request is going to your actual servers, right? And as I said that your API gateway can also help you in transforming your request and response. For example, today we are using YouTube in a desktop version. Tomorrow we have to use it in a mobile uh, as a mobile client, right? So maybe one uses simple. When we'll talk about backend services, I'll bring this example again. That okay, maybe the protocols which are being followed for these two devices are different, right? So now you don't have to worry, you just have to hook it to the API gateway and API gateway can take care of the transformation of your request. Yeah. Though, so the final bit, your content delivery network. But let's revise because today we are covering a lot of things. Let's go back a little bit. Okay. So we had to study 5 building blocks today: load balancer, your traffic cop. Okay. Your message broker, they help you in asynchronous communication. API gateway, as I told you, we went from monolithic to microservice architecture. So we need all the coordination, collaboration at a layer, right? So that can be achieved through your API gateway, right? So next one we are going to talk about is your CDN. So what are these content delivery network? Okay, for this, let me see if I can. For example, we are client, okay? We are using an application which is hosted in say UK region, okay? And we are accessing it from India. Now, what would happen for us to access the pages, right? Which are available in UK, there would be a lot of network hop, right? When there would be a lot of network hop, what would happen? There would be increase in response time. What if we introduce a concept, right, which helps us to cache? Again, this is for majorly things like these, your static content, right? So instead of going to UK, we have something in Mumbai, okay? Okay, excuse me for this. Mumbai. Okay, so what would happen now if you want to access any of these, like your front end application? It is consists of a lot of pages, and each page would have all these component. So now we know that these are the static content of the website, and we have something in Mumbai which is able to cache all these details here. So now instead of us going from, say, we are in Bangalore, and whenever we make a request, it goes to UK. But with something here, okay, what we call this as your CDN or your edge servers, they are very close to the user, right? They are close to the user. So what would happen now? All the frequently accessed your static resources, they are available here, right? So you don't have to make call to the UK server, rather you can get it from here itself. So this is the purpose of your CDNs. They are globally distributed and they're closer to the user, and this helps us in reducing the response time or latency. Okay. And similarly, okay, this is stuck. Let me. Okay. So how we are ensuring quality attributes? Again, performance, as I showed you. For example, if the request has to go from Bangalore, if the request has to go from Bangalore to UK, maybe every request or every hop takes 200 millisecond, right? So to access those pages, you're taking close to say 600 millisecond. But within Bangalore to Mumbai, every hop takes say 100 milliseconds. So you're able to reduce the response time. Okay. Similarly, if there is a lot of you see from India, there is a lot of request coming, right? So now you've already cached the resources at some edge location, like maybe for Bangalore, the edge location is Mumbai. I'm just making up the locations, but yes, based on where users are placed. If there is user in northeast, for them the edge location could be different, etc. But you are able to ensure that your application is highly available, and in when there is a surge of traffic, for example, if not only for images, text, static content, we can use CDNs, but for video streaming. So if some movie becomes super hit, right? So we know, okay, this is the movie which is being used, which is being watched again and again. So what you can do, you can cache those videos as well. So user don't have to request it from UK server, but from these edge locations. Okay. Again, how do we publish? Let me see if I can erase this. Hopefully, I can erase. Okay, yeah. So then there is publishing strategy too. Public sorry, pull and push base. You can clearly see that this is your original server. Okay, there is a CDN, right, which is like the middle layer which I was telling you, and your client browser. Okay, so the moment you are requesting for any resource, it would check if it is there in CDN. If not, it will pull it from the original server, like UK server, and now it would cache it at the CDN. Now next time if you get similar request, it would say, see if it is available here in CDN. Available, good, you get the asset in no time. But if it is not available, then again you have to look for the data in the original server. But you see, right, you have, there could be a possibility that this asset gets updated, and you want to ensure that client always get updated asset, right? So there has to be the client would always check. Okay, I took it 2 milliseconds back, right, from CDN. Go and make a request to original server and see if it has been updated in last 2 milliseconds. No, continue to give the asset from CDN itself. But if it has been updated, then you have to fetch it from the original server. Okay, and then there is another publishing strategy, which is your what do you say, the push one. Again, here the original server itself republishes the updated asset, right? Okay, so pull is like client browser has to check the original server, but with push, the original server itself would keep updating or keep giving the client browser the updated asset. Okay, so each has their pros and cons, right? Like the top one you see, there would be some latency, but what is happening, the advantage is the high availability, and you're getting latest thing, you're able to reduce the hop, etc. Okay, yeah, so this is it about today. Let me, I think, one API gateway, I think I can explain a little more, because there was no diagram, it can make it difficult to understand. Okay, so let me just draw it for you. A quick recap on API gateway. Where is my pencil? Okay, so how does API gateway works? You've got your client, okay, and then you'll have your API gateway here, right? API, I'm just writing short form, API gateway, and then there would be these servers, right? One for video, one for comment, one for notification, etc. Right? So all the security aspect, all the authorization, authentication, etc. would be taken care by your API gateway, right? Once that is done, the request would go to these servers, right? But for example, we plan to add a new server, for example, for profile, right? So again, for a client, he won't be directly exposed to this, right? Uh, for client, there would be a endpoint, right? The client would hit that endpoint, or your front end system would in that endpoint. API gateway would be the one who would be routing your request, right? So this is the advantage of API gateway. Some of the API gateway you would have heard about would be your APG, right? APG from Google. Then there are API gateway, AWS API gateway. So for every building blocks, there would be a open source version, and then there would be a cloud counterpart, right? Similarly, for messaging queue, you would have heard terms like RabbitMQ or event queue, etc. Right? So again, they see messaging broker or SQS, Amazon SQS. You would have heard about these terms. So these are your message brokers, right? Let me just quickly go through anything else we need. No, so load balancer, we talked about load balancer, we talked about messaging broker, we talked about your API gateway, how it helps in distributing the request. Yeah, then we talked about CDN, which helps us in loading the pages faster, and then there are various strategies. Yeah, so this is it for today. Again, I've covered things at a very high level, but this would give you enough information. Now you can go ahead and read about these terms, read about some use cases of all these building blocks, and make yourself more technically aware. So next session we'll talk about your backend services. Thank you.